people, and welcome. In this video, we are talking about how to solve rational equations. Now, again, rationals is just a fancy way to say fractions. So we are solving equations with fractions, but these fractions are a little bit more complicated. They will have polynomials. They will have things for us to factor. They're a little bit more complicated as usual. So speaking of usuality, if I make a mistake, I am human. Let me know so that way I may learn from my mistakes, and then you can learn from my mistakes, and you don't have to make your own. Isn't that wonderful? All right, so let's talk about steps on how to do that. Step number one, you're going to factor denominators. Step number, you guys see that? I did a step number 0. Step number 0, factor denominators. Then step number 1 is find the LCD of both sides of the problem. So basically what you're doing is you're finding the LCD, you're creating the lowest common denominator. Now for LCD is you're going to take a look at every single bubble in your factored form, and you're going to pull out each different bubble, and you're going to create the highest exponent of that. For example, if you have a x plus 3 squared on one side and an x plus 3 to the 5th power on the other side, in your LCD, you would take that x plus 3 to the 5th power because it's the same bubble, but it's the higher power. You're going to multiply each term by the LCD. This will get rid of all fractions. It's wonderful what happens. You're going to then rewrite and solve using algebra. We're going to try to get rid of all the fractions. We don't like fractions. I mean, fractions want to be loved. However, it is very difficult to love fractions sometimes, so we want to get rid of them. So once you have gotten rid of all of your fractions, you're going to rewrite using algebra, and you're done. When you have solved for your variable. The whole purpose of solving equations is to get what the variable is. X is equal to a number. It can be x cubed, whatever variable it is, but you're done when you have a number. Sometimes you're going to have multiple solutions. You can have a number and a number. It can be multiple solutions. You're going to plug in the answer into x. You're going to plug in your answers into x to the original equation. You're going to check for extraneous solutions. Now, extraneous solutions are things that you solved for but don't actually work. So if I solve for 3 and I take 3 and plug it into my original equation and it doesn't give me a true statement, therefore the answer of 3 is extraneous and it is excluded from my final answer statement. All right, what I would recommend you guys is pause this video, write down all of these steps. Again, while we're doing these examples, maybe there's going to be some changes to these steps, but at least you have them written out before we begin. Alrighty, so for example number 1, what we're doing is we have 6 over x plus 4 and 1 over x is equal to 1. Now, I went ahead and I put these bubbles around x plus 4 and x, and the reason I did that is because I noticed that x plus 4, the exponent on x is 1, so we can't factor that. And x is just the exponent on that is 1, so we can't factor that. So for step 0, we are factoring the denominator. Step number 1, we are finding the LCD of both sides of the problem. So what I mean by both sides of the problem is using both sides of the problem, find the LCD. So here are the x plus 4x. Now, the both sides of the problem is if you have like a dotted line here, when we're solving an equation, you would actually have a fraction here. But in this case, it's just 1 over 1. So you can just, I'm going to do it, but you have that denominator. So you're looking denominators on the left-hand side and on the right-hand side. It has to be a LCD for all denominators, not just on one side. So since we have the denominators on both sides, you would also include the bubble of 1, but since 1 doesn't change anything, I'm going to omit that. All right, so LCD, how do you determine what an LCD is? So the lowest common denominator is taking every single different bubble from each denominator and writing it. So for example, in this denominator, I have x plus 4. In this denominator, I have x. Now, are you only writing the bubbles? No, you're taking the exponent with it. For example, let's do a quick example. I actually do it on a separate sheet of paper. Separate sheet of paper, if I can find it, that would work. Okay, so on a separate sheet of paper, I'm just going to show you an example. What I mean by that is if I have, let's say, 3 over x plus 7 squared, x plus 4, and you would have 5 over x plus 7 to the 8th power, x plus 4 squared, what you would do is for your LCD, you would take all the different bubbles. So for example, I have an x plus 7 bubble here. I have an x plus 4 bubble here. I have an x plus 7 bubble, which I already have. And I have an x plus 4 bubble, which I already have. So what I now am looking for is the higher exponent. So I have a higher exponent of 8 for this bubble, and I have a higher exponent of 2 for this bubble. So in your LCD, you would have the same bubbles with the higher exponents. Okay, so if we had like another x, plus 2, then I would have x plus 2 here. So it doesn't matter how many different bubbles you have, you're taking the exponent that is the highest. So x has an exponent of 1. X plus 2 has a highest exponent of 1. The other one has a highest exponent of 8 and a highest exponent of 2. Okay, let's go back to our question. So now that we have determined our LCD, we're going to go to step number 2, which is multiply each term by the LCD. This will get rid of your fractions. What that will look like. What that will look like is you're taking your 6 over x plus 4 bubble plus 1 over x is equal to 1. And you're multiplying that by your LCD. So I'm going to multiply every single term, x plus 4 times x, on this one. For this one, I'm multiplying x plus 4 times x. And for this one, I'm multiplying x plus 4 times x. So what this will look like, maybe using both blue colors isn't the smartest idea for me. Well, let's go ahead and do that. So you have x plus 4 times x times 6 over x plus 4 plus x plus 4 times x times 1 over x equals x plus 4 times x times your 1. So here are the same two sides of our equation. Notice that, again, we're going to simplify top and bottom. For example, I have a top of x plus 4. I have a bottom of x plus 4. That means those two bubbles get to cancel out. What am I left with? I'm left with x times 6 plus. I have an x on the bottom. I have an x on the top. That means those two cancel out. I have an x plus 4 times 1. I don't have anything in the denominator. Technically, I have that 1, but that doesn't change anything. So I have my x plus 4 times x times 1. So now I'm going to re-simplify these, make it prettier. So I have 6x plus 4. And this is x squared plus 4x. So now I'm going to simplify, combine like terms. So what do I have here? I have 7x plus 4. And this is x squared plus 4x. I'm going to subtract 4x both sides. Ooh, there you go, 4x. Running out of room, so I'm going to write it up here. So I have, what do I have left over? I have 3x plus 4 is equal to x squared. All right, you guys, this is when something cool happens. I'm going to want to set it equal to x squared. Let me back up. I'm going to want to set it equal to 0. So let's go back to our steps. It says rewrite and solve using algebra. So you're going to say, if you can just solve basic algebra. If you have an exponent, get all terms to one side. Make it equal to 0. And factor. So in this case, let me show you what I wrote. There it is. So in this case, I have an exponent of 2. So I'm going to get everything to one side. So I'm going to say I have 0 is equal to x squared minus 3x minus 4. I'm going to factor, which this give me 2 terms to multiply to 4. Give me negative 3, so it's 4 and 1. So here are my factors. And so then what I'm going to do is I'm going to set these equal to 0. So I'm going to say 0 is equal to x minus 4. And I have 0 is equal to x plus 1. So what is x equal to? X equals to positive 4 and x equals to negative 1. So now I have two possible x values. So how do I know which one's which? And how do I know which one's actually going to work? So you're going to take these two values, you're going to plug it into your original equation. You're going to plug it into your original equation. So in my head, you can do it in your head, and you don't have to do it in your head. I'm doing your check. So I'm doing 6 over plus 1 over is equal to 1. So I'm checking if both of them are going to equal to 1 when I plug it in. So if I plug in 4 here, will that give me 1? So 6 divided by 4 plus 4. Well, 4 plus 4 is 8 plus 1/4 is equal to 1, maybe. I'm going to do like terms. I'm going to multiply top and bottom by 2. So that gives me 6/8 plus 2/8. Is that equal to 1? Well, 6, 7, 8, that's 8/8, and that is equal to 1. So that gives me a check that x is in fact equal to 4. Now let's do another check. This time I'm checking negative 1. So I have 6 over negative 1 plus 4 plus 1 over negative 1. I'm doing that on purpose. So then I have 6 over 3. 6 divided by 3 is 2. Oh, let's simplify that. That will make it better. So I have 2 minus 1 is equal to 1, and yes. So that means I actually do, in fact, have both answers being my solution, and there are no extraneous solutions. All right, let's do one more. Yeah, let's do this one. This one has a lot of fun stuff for us to do. So this is, in fact, example number 2. We just skipped example number 2, and we moved on to example number 3. All right, so step number 1 is you want to factor all of your denominators. So I'm noticing that these two are the same, which I'm doing a happy dance. So this one's going to be m minus 3 and m plus minus 1, excuse me. So m minus 3, m minus 1. So then in my LCD, I'm taking all of my bubbles. So m minus 3 here is in a bubble. I see another m minus 3. I have an m minus 1 in a bubble. I see another m minus 3, but I already have that. And I see an m minus 1. I already have that. I'm checking my exponents, and I'm taking the highest exponent that I have. In this case, all of my exponents are 1. So my exponents for my LCD are 1 as well. So now we're going to take that LCD, we're going to multiply each term by it. So I'm multiplying this by m minus 3, m minus 1, m minus 3, m minus 1, m minus 3, m minus 1. Now here's the thing, you guys. I am noticing that this right here can be factored as well. So before I'm going to multiply anything out for that term, I'm going to factor as well, because it's going to give us, an easier solution, maybe. So let's go ahead and multiply out. I see a m minus 3, m minus 3, those cancel. So what do I have left over here? I have 2 times m minus 1 for this term. I have an m minus 3, m minus 3, m minus 1, m minus 1. So I'm doing a happy dance because all of these cancel out. So what am I left over with? I'm just left over with that 30m plus 25. Here, what am I having? I have an m minus 3, m minus 3, m minus 1, m minus 1. So what am I left over with? These cancel out, these cancel out. I'm left over with just 1. Now we put our dotted line, and we're going to continue multiplying or factoring things out. In this case, I have 2m minus 2. Here I have 30m plus 26. Again, what's our goal? Our goal is to get m equals to something. I'm noticing I don't have an exponent. My exponent is 1. So since my exponent is 1, I'm just going to continue algebraically. I don't have to set anything equal to 0. So I'm going to add 2 to both sides. No, I will not. I'm going to subtract 26. And the reason I'm going to subtract 26 because I want my m to be positive, so I have a negative 28. I'm going to then subtract 2m. So I have a negative 28 is equal to 28m. So m is equal to 1. Again, check for extraneous solutions. We're going to plug it into our original equation. Now you can choose to put it into the factored form. That's up to you because they're equal. So I'm going to do that. No, what? I will not do that. I'm just going to stick it to the original. And we're double checking our answer, which is 1. All right, let's see what we have. We have 2 divided by negative 2 is equal to 30 plus 25 divided by 1 minus 4 plus 3 plus 1 over 1 minus 4 plus 3. We're going to need a little bit more room than what I gave myself. That's okay. So I have negative 1 is equal to, this is 50. What is this? 4, 5, 55 divided by, this is negative 3 plus 3. Ooh. Ooh. Do you guys see that? Do you guys see what just happened? It's not even the numerator, that 55 that scared me. It's this. Negative 3 plus 3. Well, what is negative 3 plus 3? Negative 3 plus 3 is 0. We cannot have a 0 in the denominator. If we have a 0 in the denominator, the world explodes. So therefore, it does not work. Therefore, negative 1 is extraneous. Since we only have one m possibility and it is extraneous, our final answer is no solution. Like the other one, we check if we have more than one possible m and we checked one worked, one didn't, that's still, you can still then answer. But because we only had one and that one is extraneous, therefore we have no solution. All right, beautiful people, that is how you solve rational equations. If you have any questions, please reach out. If you caught a mistake, also reach out. As always, thank you so much for watching my video, and I will see you in my next one. Bye.